Hey guys, so in this video I'll be talking about the problem next permutation. So I'll be going over the problem, explaining the solution and the implementation, and then wrap up with the runtime analysis. So in this problem it wants you to rearrange an array of numbers so that it's the lexicographically next graded permutation of numbers. Basically it's just make the next number that's larger than your current number. So if you have 123, well, given these three numbers, I know I can also make the number 132. And I can't make any number between 123 and 132, so that's like the next bigger number I can make. And if it's impossible, because if you're given 3, 2, and 1, the largest number you can make is 321. Just return them all in sorted order. And yeah, and so for example, this one, 115, the next number after 115 is 151. And yeah, and well, a couple other constraints, the length of the array isn't that long, so yeah, and the replacement must be in place, so you can't really allocate a new array or anything like that. So let's get into the solution, and to understand the solution, let's first build on the observation that we made earlier, which is that given these numbers, you're basically tasked to find the next number that's just bigger than your current one. So yeah, so 123, the next one's 132, stuff like that. So how do we find that? So an observation that we can make is that if we swap, let's just say this is a 1 and this is like a 3. If we swap a larger number into a smaller number, if we reverse their order, we will make a larger number, right? That much is pretty obvious. And so how do we make that larger number as small as possible? Well, we don't want to swap it all the way to the start because let's just say we have like 123. We don't want to make 300 something because that's just skipping a bunch of numbers. But if possible, we'd want to swap it with the closest one possible. And in this case, we can, and we can get a larger number because 32, right? But what happens if you can't? Let's just say this is a 4. Yeah, well, in this case, you'd want to swap it with this one, but you can't. So then you see if you can swap it with the next one. So like you see if this number can be swapped out. And if it can, that's the best you can do because that's you always want to be swapping to like the smallest digit you can. So if there's like 5 digits, you always want to try to swap the number at this digit before like this one, okay? And yeah, so now let's get into yeah, and one more thing before we get into the algorithm, the actual hard like algorithm, is that after you perform a swap, so let's just say like 3 and 1, after you perform a swap, so you swap these, now all these numbers here, you just want to sort them because since you already know you made a bigger number, if you have like 9, 5 here, you don't want like 3, 9, 5, 1. You just want to sort these. So then it'd be like 1, 5, 9. So that's because you know you made a bigger number, so now you make the rest of the number as small as possible. So yeah, that's just one last thing to add on before the solution. And so now that we want to know, now that we know that we want to make the number bigger, but at the smallest possible like spot. So what we can do is we can first check if this is like the ones place, we can first check the tens place. Can we swap anything? Is there anything on this side over here? Well, there's only one digit, right? Is this digit here? Can we swap it here? Can we perform a swap? If we can't, then we go to the 100th place. Then we check, starting from this 100th place, can we swap it with the tens place or the ones place? Let's just say, yeah, so let's just say you have 3, and then there's like 1 and 2. We know, yeah, we can't swap it, but if we have like 1 and 4, then we know, yeah, there's a swap. So we can make the 100th digit bigger, and we wouldn't ever want to make the thousandth digit bigger, because then you're just skipping from the hundreds to the thousands, and that's not like the next biggest number. And so you would just keep on doing that. And so the first digit where you detect that you can swap, so let's just say, hey, in the thousandth place, I've finally found a number small enough. So let's just say this is like 6, 5, and 4. Like, hey, I finally found a number small enough where I can swap a number in, and it'll make the number overall bigger, because we'll first check the tens place, then we'll check this place, hundredth place, and compare it to this and this, right? And then we'll be like, okay, I'll try the thousands place. Let me check all the numbers to the right of the thousands place to see if there's a number that's larger than it. And yeah, we see that there is. So now the question is, which one do we swap in? Well, it's pretty common sense. You want to swap the smallest one in, because like 4,000, that's the next. You just want to swap in the one just larger than your current one. So if you had like a 2, then perfect. You want to swap that 2 in. And let's just say like the numbers are reversed. This is a 2, this is a 4, same deal. You want to swap the 2 in, and then these numbers 6, 5, 1, and 4, you just want to sort them to get the rest of the number as small as possible. So yeah, it's pretty intuitive if you think about it. You see the first digits place where you can perform a swap that makes the number bigger, and then you swap in the smallest possible number that makes the number bigger, like still. And then after that, the rest of these numbers, you just sort them, and that makes the smallest possible number that's still bigger than your current one, which is the next permutation. So let's just quickly describe how this code actually does that. So this I here will go from this digit here, and it'll just keep on going. And our logic is basically, if we look at I, is there any number to the right of I that we can swap it with? So this is what we do here. So j is to the right of I, and we add to it. And if that number is greater than our like current number, then we keep track of it. And this check here, just make sure we find the minimum number that's still bigger than our current number at nums I. So that way we'll be able to know to swap in 4 instead of 5 or 6, because yeah, that's what we discussed. And so we keep track of the index of that number that's just larger than our current number and still to the right of it. And then we'll keep track of what that number is, of course, so we can compare it. And then if we find one, so since I set this to -1, if we find a number that's to the right of it and we can swap it, and we know that's the smallest possible number that's still to the right of it that we can swap in, then we'll perform that swap. And because this says the replacement must be in place, I just used the first in place sorting algorithm that I could think of. Well, I mean, I don't know for sure if I should probably check this, but I don't know for sure if the arrays.sort is in place or not. It probably is, but I should probably check this. But I know this would work because the length isn't that long, so it's really simple to code. So I just coded bubble sort, and then after you perform the swap, you just sort the numbers after it. And if I checked every single spot, I can't make a larger permutation. That means I know I must be in this case where it's already largest. I'll just sort the array starting from the start. And this is just a bubble sort modified for sorting an array from a starting index. Yeah, it's not too relevant to the problem because there's a lot of sorting algorithms that would work given the small input size. But yeah, I'll include a link if you need to read up on it to understand. But yeah, let's just submit this to prove that it works. Yeah, and it is quite efficient, as you see, with memory. It's not the fastest because there are more efficient sorting algorithms that you can use, because I'm just using bubble sort because it was easy to code. And so the runtime of this should be, well, in the worst case scenario, you'd have to like sort the entire thing with bubble sort, so that'd be O of n squared. So yeah, that's about it. Thanks for watching the video, and I'll see you guys next time.